Alright, now that we have the unit circle completed, we're going to go ahead and try to use the unit circle to help us figure out some of the trig values that are located at the bottom of the page. Before we get started though, I do need to make a correction. I made a mistake. I'm human, it happens. I'm sure you're going to make a bunch of mistakes this year as well, but the point is that we correct them and learn from them. Hopefully you caught my mistake. That's what I get for working too fast and not being thorough enough. This ordered pair at the very top should be 0, positive 1. And the ordered pair at the bottom should be 0, negative 1. Okay, I got those a little flipped. So now that our unit circle is complete and accurate, let's go ahead and see if we can use it to figure out some of the values at the very bottom. So the first three on the left-hand side, notice how these are basic trig functions: sine, cosine, and tangent. We're going to go ahead and use the unit circle to figure out those values at these particular radian locations. So when you're dealing with a typical trig function like sine, cosine, and tangent, the argument, meaning the value that's inside the parentheses, is representing a radian location. So we're going to try to figure out what is the sine, cosine, or tangent value at this at this radian location on the unit circle. So let's go ahead and first find pi over 3 on our unit circle. Notice how that's in the first quadrant, and we want the sine value of that spot, meaning the sine value from the ordered pair. Now previously we said the sine value represented the y-coordinate, so at this spot on the unit circle, the y-coordinate, therefore the sine value, is square root of 3 over 2. Not too simple. We're just reading the unit circle, trying to find specific values. Next one, we want the cosine value from the pi or 5 pi over 3 location on the unit circle. That's in our fourth quadrant right here. And the cosine value is the x-coordinate, so we'll simply write 1/2. Now tangent can be a little tricky because we defined tangent to be the sine value divided by the cosine value, meaning y over x. So let's go ahead and find the pi over 2 spot on our unit circle. Okay, that's the radian that we want to locate. Now that's at the very top, aka 90 degrees. So we need the y-coordinate, which is 1, divided by the x-coordinate, which is 0. Now hopefully light bulbs are going off in your head at this point. We cannot divide by 0, so therefore the tangent value is undefined at this location, meaning there isn't a tangent value. Alright, so those are basic trig functions, sine, cosine, and tangent. We can look at the inverse trig functions, meaning arc sine, arc cosine, and arc tangent. What's tricky is that those inverse trig functions can be represented two different ways. You can see the word arc written in front of the trig value, such as the example of arc sine and arc tangent, but you also might see the inverse symbol of a power of -1. All of these represent an inverse though. So in an inverse, we kind of have to flip what these values represented. Notice how before the argument represented a radian and the answer or the output represented a value. Okay, specifically found on the unit circle. If we're going to apply an inverse, that now means the arguments are values from the unit circle and the outputs should be the radian locations on the unit circle. So we're kind of doing a little switcheroo here. It's not too difficult, it's just reading your unit circle in a different fashion. So let's take a look at our first one. We want a sine value of 1/2, and we're going to go ahead and write where that happens on the unit circle. Okay, at what at what radian locations does that happen? So sine is representing a y-coordinate. If we go ahead and take a look at our unit circle, we have a y-coordinate of 1/2 at pi over 6. But if you pay close attention, we have another one over here. Notice how we have a y-coordinate of 1/2 also at 5 pi over 6. So in this case, we actually have two solutions. We can say pi over 6 but also 5 pi over 6. So the sine value is a half at these radian locations on the unit circle. For our next one, we want to figure out when does cosine have a value of negative square root of 3 over 2. So that would be an x-coordinate of negative square root of 3 over 2. We have one of those at 5 pi over 6. And it looks like we have another one at 7 pi over 6. So again, we actually have two solutions in this case. You might not always have two, but just want to show you that that is a possibility. All right, last but not least, we want a tangent value of 1, meaning if we were to take the y-coordinate divided by the x-coordinate, we would get 1, and we want to figure out when that happens. Now, we got to think about strategically what this division is representing. If our answer is 1, that must mean that whatever we're dividing by, the numerator and the denominator should be the same. And they're both positive or both negative, because notice how our solution has to be a positive 1. So on our unit circle, we want to find an x value and a y value that are exactly the same, meaning both positive and both negative. Let's see, that looks like it happens at pi over 4, where we have both a positive square root of 2 over 2, and maybe 5 pi over 4, where we have both a negative square root of 2 over 2. So we have two solutions again. We can say pi over 4 and 5 pi over 4. All right, so that wraps up our review unit for this year. We're going to dive into our first actual concrete calculus unit next. We're going to be talking about limits. So buckle your seatbelts. We're going to get this ride started.